All right, Unit 12, Note 4, solving equations over the complex set of numbers. So in the last set of notes, in Notes 3, we did roots of a complex number. But we kind of cheated and we kind of peeked ahead because we really set it up as x to the n equals something, and then we did the nth roots. So today we're going to officially have an equation that looks like x to the n. So in this section we will apply that concept, the roots concept, to solving equations for all solutions, both real and complex. The process is exactly the same as what we did on Friday, but Friday we said find nth roots. Today we're going to say solve an x to the n equation, but it's kind of the same thing, it's just a different setup. Remember that the fundamental theorem of algebra states that a polynomial of degree n has n solutions, right? We've talked about that before. So every 5th degree polynomial has 5 solutions, every 8th degree has 8 solutions, and so on. Number 1, determine all solutions, real and complex, to this equation. Give your answers in reduced trig form. Oh, I like this one because we like trig form because that's the angles and we don't have to do anything further. So I like this question. How many answers am I going to have? Should be 4 solutions. So x to the 4th equals negative 256i. I want a 4th root both sides, but before I do that, I should probably rewrite negative 256i as a trig number. That way I can use the trig tricks with the 4th. So let's see, this is the real axis and the imaginary axis. So negative 256 would be down here. So that angle is 3 pi over 2. We converted from standard form to trig form. We need it in trig form so that we can do the trick with the 1/4. So now we'll raise each side to the 1/4. So x equals, that's the easy part, 256 to the 1/4. 4 to the 1st is 4. 4 squared is 16. Yeah, so 256 to the 1/4 is 4. And then what do I do with that angle? Multiply it by the power. So 3 pi over 8. Friday we called that the principal root, the first root, the first answer we get. We know that's not our only answer because there's 4 more to be had. How do I get to the other 3 answers? I'm going to add 2 pi over 4. Or pi over 2. Oops. Which would be 4 over 8. Common denominator here. So 7 pi over 8. 11 pi over 8. And 15 pi over 8. That's 4 answers. If you want to go one more to check, the next one would be, let's see, 19 over 8, which is 3/8 passed all the way around. So 19 over 8 would match up with that first one. So it's not an answer, but if you want to go one more to sort of confirm that you hit all the spots the right place, it's not a bad idea. Answer in trig form, so we like that. The answer in angle form. Oh, they couldn't have asked for this one in standard form anyway because we don't know the cosines and sines of the over 8s. So we're done with number 1. as opposed to number 2, which it says standard form. So my answers will need to be a plus bi. Oh, how many answers am I going to have? 6. X to the 6th equals negative 64. But I would like to write that in trig format so that my trig tricks work easily. So where is negative 64? Up, down, left, or right? Left, because that's the real axis. So over here is negative 64. So the r is 64 and the theta is pi. Now we're eligible to use the 1/6 trick. So the 6th root of 64 is 2. Divide by 6, we get pi over 6. And I'm trying to leave room on the right because I know I'm going to have to convert in a minute. So I'm going to do my scratch work here on the left. So how do I get to the other answers? What do I need to add? 2 pi over 6. Which would be pi over 3, but I think I want to leave it like that. That way I have a common denominator built in. So 2 cis pi over 2. And then 3/6 plus 2/6 is 5/6. And now I'm just adding 2/6 each time. So the next one is 7/6. And the next one is 9/6, but that reduces. And 9/6 plus 2/6 would be 11/6. And I guess if I wanted to confirm that, 2 things I could do. I could add pi over 6 again, or 2 pi over 6, and get back to where I started. I could graph those and sort of visualize that pi over 6, that all of those are equally spaced, and they are. I wish they would let us leave it in trig form because we'd be done. But instead, we got to convert. Somewhere in here, a bunch of you are going to start skipping steps because you just get tired of writing all this stuff out. Oh, here's where my picture is helpful. Cosine pi over 6 is root 3 over 2, so root 3. Sine of pi over 6 is a half, so plus I. Cosine pi over 2 is 0. Sine of pi over 2 is 1, so that's 2i. And I wrote it over there so that all my I numbers will be lined up and all my real parts will be lined up. Cosine 5 pi over 6. I sine 5 pi over 6. Cosine 5 pi over 6 is on the left. So that's negative root 3 over 2. So negative root 3. Sine's still positive, so plus I. And then just to encourage some of your reckless behavior of not showing work, cosine 7 pi over 6 is negative root 3 over 2, so negative root 3. But then the sine is negative a half. Cosine 3 pi over 2 is 0. Sine 3 pi over 2 is negative 1, so minus 2i. And then 11 pi over 6 is positive for the cosine, negative for the sine. So there's my 6 answers. Show the work you need to show, but I realize that some of you are going to be doing a lot of this stuff in your head. Which is okay, it just makes partial credit more difficult, and it makes making mistakes little more likely. So be cautious.